Good morning, everyone. My name is Ben Miller. I'm a PhD candidate in the Laboratory for Bioinspired Photonic Engineering at MIT. Joining me today is Andrew Blair and Professor Matthias Koller. And over the next few minutes, I'm going to talk to you about how understanding butterflies can help us treat the medical condition called venous ulcers. Now, let's start with a butterfly. What's interesting here is that the bright blue color you see on the wings isn't caused by pigments or dyes. Instead, if we zoom all the way in, we would see something like this. These are nanoscale structures you find on the surface of the wing. What these do is cause light to interfere with itself, selectively reflecting certain colors and not others. This is essentially the same as the physics behind the colors on a soap bubble. So for the past few years, my research has focused on how to develop synthetic materials like this, but with one important twist, that they're also elastic. What this means is you see a sample of our material on the bottom right here, that as the material is stretched or compressed, these embedded elastic nanostructures in turn are stretched or compressed, leading to a predictable and reversible change in the color you see. Now, there's a few different things we'd like to do with this, but the most pressing problem we want to tackle is that of venous ulcers. So I apologize for the graphic image here, but this is a chronic wound found on the lower leg. Now, it's caused by the relative inability of the blood vessels in the leg to return blood back up to the body. It affects up to 3% of the population, and that correlates with an aging population, so that number will only go up. It also can take over a year to treat, so it causes significant discomfort to a large number of people. Speaking of treatment, the best course right now is quite simple, actually. It's compression therapy. And so you tightly wrap a bandage around the leg, providing mechanical assistance to those blood vessels to help get blood back up to the body. The effectiveness of this is strongly dependent on how much pressure you apply. So we take a look at this graph here. This is showing the percentage of ulcers that would heal over a period of time. And as you increase that pressure, that number goes up. You can heal it significantly faster by months with the right pressure. But what isn't shown here is that you can't go too far in the other direction. If you apply too much, there's discomfort for the patient. You cut off circulation to the lower leg, causing secondary medical issues. So really, there's a sweet spot here. The problem is, however, that even experienced medical professionals will get this wrong up to 30% of the time. So what we need is a new approach that allows medical professionals or even untrained patients themselves to apply the correct amount of pressure every time. And what we've done to do this is take our color-changing material and bonded it to a compression bandage. What this means is that the color of the bandage is a visual indicator of how much pressure you're applying. In this case, red would mean not tight enough, blue would be too tight, green would be just right. By using this visual indicator, we can allow even untrained people to apply the correct amount of pressure every time, saving months of discomfort. At this point, there are two questions to ask. One, does this work medically? And two, could we make a business out of it? And I'm going to start by addressing a few points on that second question. So the material itself is reliable and robust. We've cycled it 10,000 times, put it in the washing machine, put it in the oven, and there's no obvious change to the optical or mechanical properties of the material. Filed a provisional patent on this. And thanks to the funding and advice from the Deshpande Center, we've developed a prototype roll-to-roll manufacturing setup. Enough material to cover a 3-meter-long compression bandage costs us currently around $2 to make, and that's not optimized at all. And to put that into context, I went to the store and bought a top-of-the-line bandage off the shelf. It would cost around $30. So we're in the right ballpark in terms of the cost of the material. And to put that into context, so the compression therapy market is expected to reach $5 billion over the next few years. Now, onto the first question, actually, does this work medically? So we have one piece of information I showed you earlier. There's a study showing that if you apply the right pressure, you reduce treatment time. What we did in our lab, though, was with an earlier version of this, do a complementary study where a group of students were taken, and they were asked, using different types of bandage, to apply a bandage with a certain target pressure, represented by the dotted lines on these plots here. 3 bandages were tried, cheap off the shelf, the high-end off the shelf, and the custom one. And as you can see with the top plot here, the cheap one, the target pressure was under where it should have been. With the top of the line one, it was over, but with the color changing indicator, it was consistent and accurate. So what are our next steps? Well, one of them is to look at more clinical testing, ideally a clinical trial. Now, we have all the pieces of information to, I think, make a strong case that this works, but what we really want to do is have an end-to-end story that says if you use this bandage, we can reduce treatment time by X number of months. We're also continuing our work on customer discovery, partly through the ICOR program, basically talking to different medical professionals and getting the bandages into their hands. So what are we looking for in terms of help at the moment? Well, firstly, connections in the healthcare space are always valuable, particularly people who will be willing to try this material and these bandages out. Potential investors. So I am going to be defending my PhD in the next couple of months, and then we'll be looking to start doing this full time. Potential team members. We'd love to, anyone you may have a connection to would be great to speak to. And also the most fun part of this, other application ideas. Everyone always has a lot of things they can think of to do with a stretchy, color-changing material, and we're always keen to hear more of them. I'd like to thank the rest of the team, particularly thank the Deshpande Center and our advisors, Paul and Brian. Please do come check out the poster. Thank you very much.